This is Trig quiz review number 1. Let's look at number 1 here. State the period and amplitude of the function y is equal to 1/2 cosine of pi x over 2 plus 7. Now, for sine and cosine, the period of the parent graph will always be 2 pi. And we always do 2 pi divided by the absolute value of b to determine what the new period is. And the amplitude is always going to be the a value that is in front of the cosine or sine function. So in this case, to find period, we simply take 2 pi and we divide it by b. Our b value is the coefficient that is in front of the x inside the cosine function. So in this case, our b value is pi over 2. So plug into our formula, 2 pi divided by pi over 2, and we flip the pi over 2 to be 2 over pi. 2 pi times 2 over pi reduces to be 4. So our period is simply 4 units. Amplitude is just 1/2. Number 2 states the period and amplitude of the function y equals 3 tangent of 2x minus 4. Tangent functions will not have any amplitude, so this is none. The parent graph for tangent of x has a period of pi, so then we have pi over the absolute value of b to determine if there's any transformations there. So our b value here is the 2, so pi over 2, we simply have our period, the time that it takes for the tangent function, this tangent function to complete its cycle is simply pi over 2. Complete the following identity. Cosine of 2 theta. We have 3 identities here. Cosine 2 theta can be expanded to be cosine squared minus sine squared, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. And also want to remember that sine of 2 theta, double angle formula, becomes 2 sine of theta cosine of theta. And a lot of times we choose the appropriate identity depending on the equation, and many times we want to choose the one that will work our equation down to just one trig function. So if we look at number 4, solve the equation cosine of 2 theta plus 2 cosine of theta. Now we have this cosine of 2 theta that we have to get it out of the double angle, so we want to choose the appropriate one. And we see that we have a cosine here, so most likely it'll be the 2 cosine squared theta minus 1. That way we can get this down to just be one trig equation. So we'll replace cosine of 2 theta with 2 cosine squared theta minus 1 plus 2 cosine of theta is equal to negative 1. We can clean this up a little bit. Move the 1 to the other side, or actually if I add 1 to both sides, it goes away. Now I'm just down to 2 cosine squared theta plus 2 cosine theta. Factor out the 2 cosine theta, and then parentheses we have cosine theta plus 1 is equal to 0. So we set each part equal to 0. 2 cosine of theta is equal to 0. Divide both sides by 2. We have cosine is equal to 0. Cosine is equal to 0. Let's look at our restrictions here. We know that cosine is equal to 0 at pi over 2 and 3 pi over 2, and that falls within our domain, so we're okay. Cosine, the other parentheses, cosine of theta plus 1 is equal to 0. Subtract 1 from both sides. Cosine theta equals negative 1. And when is cosine equal to negative 1? It'll be at pi. So theta is equal to pi. So you have 3 solutions for theta: pi over 2, 3 pi over 2, and pi. Number 5, limit as x approaches 4 for tangent of pi x over 3. The first thing that we do when we want to evaluate a limit is we just plug in that target x value. So plug 4 in for x, and we get tangent of 4 pi over 3. We can just evaluate this. Tangent of 4 pi over 3 is simply going to be root 3. Okay. Limits as x approaches 0 of sine of 4x over 9x. So the rule is that if I have limit as x approaches 0 for sine of ax over bx, then that's simply equal to a over b. Okay, so this is one of the trig theorems that's available to us. So sine of ax over bx is equal to a over b. And in this case, we can simply say that the limit is 4 over 9. Okay, number 7, limit as x approaches 0 of 1 plus cosine x over 2x. Now, we have a rule which says that limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. And this does not match the rule that is available to us. And if we plug in 0 in for x, we're going to get 1 plus 1, which is 2 over 0, and we can't do anything with that. We can't cancel anything out. We don't have any rules available for us to use. So this limit does not exist. It'll be undefined. Okay, limit as x approaches 0 of 4 sine of 7x over 3x squared. If we plug in 0, we'll get 0 over 0. So let's see if we can expand this a bit. Sine of 7x over 3x. Well, we know that sine of 7x over x, we can replace that to be 1 using our limit theorem here, our trig theorem. 4 over 3 is the coefficient, so that stays 7 over 1. Now, this 1 over x, this x is not going to go away. If I replace this remaining x with 0, we're still going to have that 0 in the denominator, and it will not cancel out. So even though the first x in the denominator went away with the trig, with the sine theorem, the second x will not go away. So we're left with a 0 in the denominator, so our limit remains undefined. Number 9, limit as x approaches 0 of tangent of x over x. If I replace 0 in for x, I get 0 over 0, which is undefined. We don't have any trig theorems in terms of tangent, but we can rewrite tangent in terms of sine and cosine and see if we can use one of the sine or cosine trig theorems to help us find the limit. So let's replace tangent in terms of sine over cosine. So sine over cosine all over x. I can bring this x up to the top by cleaning up this complex fraction. And if I bring this x up to the top, I'm left with sine of x over cosine x times 1 over x. And that's simply equal to limit as x approaches 0 of sine of x over x cosine x. Now we can see what property we can use. Sine of x over x, we know as x approaches 0 is simply equal to 1. So that's equal to 1. And then the 1 over cosine of x, I can replace the x with 0. And this is 1 times 1, which gives us 1. So we do have a real number. So this is our limit. Okay, for number 10, limit as x approaches 0, 3 sine of x minus 3 sine of x cosine of x. I can factor out this 3 sine of x, and I have 1 minus cosine of x over x. So if I split this up, I'm going to have 3/5 as a coefficient, sine of x over x, and then 1 minus cosine x over x. I'm rearranging the variables so that I can get these properties to match. So this matches the sine property, which reduces to be 1. This becomes 0. So I have 3/5 times 1 times 0, and that's a real number, which will be 0.